Hello all, welcome to LTX classes. In this class, we shall look after the Hindu important explainer that the Hindu carries every day from Monday to Thursday, okay, Friday, and this is from text and context part, okay, this is from text and context part where we shall be discussing the article that have come and which are very relevant for the UPSC in the pattern of mains preparation. So if you watch these videos continuously as a series where we shall be releasing every day, you shall be getting a lot of information regarding mains, clear, and in the current affairs perspective. Fine, see, check. Today we have taken the article that has appeared in the Hindu, that is the search for dark matter, the search for dark matter, where we shall be discussing about the dark matter. See, UPSC generally asks these type of things in very normal perspective. So in very normal perspective and to the required level, we are going to intercept this article, clear. See, article is being discussed by, this is Srinivas, and look after the question where we shall be discussing every day one question in the mains perspective mode, and we encourage you to write the answer, clear, and please write the answer in the comment box and I shall be reviewing it. See, question, still the concept of dark matter is an elusive one. Explain. Sir, what is elusive? Elusive means which does not have proper explanation. Those things are called elusive in nature. Are you getting? So that's why UPSC often gives these type of names or terms to actually destabilize the persons who are writing the mains, right? But what is the meaning of elusive? Elusive means which does not have proper explanation. So here see, the question is about the concept of dark matter. Still many years and science has evolved in such a manner, but still we are finding it very difficult to get the real minimum extracts from the dark matter. Okay, so have this article. This is the article that has come, the search for dark matter. Okay, the article is being discussed in GS 3 science and technology, clear, science and technology. This is the part of science and technology, dark matter and everything. Okay, let's have, we shall discuss the present context also. Fine, go with this. Before understanding what is dark matter, you should understand first of all what is the matter. Okay, right? So first of all you should get what is the matter. Matter means it is a substance. Matter is a substance made up of various particles. Are you getting? Made up of various particles. To call something as matter, these particles should be present, right? So to call something as matter, it should contain some particles, and that particles should occupy, these particles should occupy certain space, clear. It should occupy certain space, and after that it should have the inertia. Inertia means movement. It should have some inertia, then only these particles are called as matters, right? So it is a substance made up of various particles, clear. So then only something is called as particles and matter. Most examples of material particles are generally what we see: electrons, protons, neutrons. So these material particles holds electrons, protons, neutrons. So all these things are called matter, right? So in the matter form we shall see the solid stays in the form of ice, right? The liquid stays in the form of water, and the gaseous stays in the form of evaporation, right? Clear? So are you getting? The matter consists of present solid form in the form of ice, liquid form in the form of water, and the gaseous form in the form of evaporation. Are you getting? So in this way we generally look after the examples of matter, right? So look after this. Now we are going to discuss something related to dark matter right now. So then what is this dark matter? Okay, often scientists or cosmologists who study the space or related particle physics, we shall be dealing that. So dark matter is made up of particles. It is made up of particles. Why particles should be there? To call something as matter, right? So dark matter is made up of particles that do not have any charge. This is the main difference, that do not have any charge. So for every article or for every particle and matter that we can observe in our earth is having some energy or some charge form in it. But in dark matters we cannot see this charge. The absence of charge make it called as the dark. So these particles are called dark because they do not emit any light. They do not emit any light. Are you getting? So they do not emit any light. So with our naked eye we cannot see that. And next, it does not have any charge. Generally every particle holds some charge in it, right? But this dark matter does not hold any charge actually. So if they does not hold any charge, they does not emit any light. If they are not emitting any light, they cannot interfere with electromagnetic spectrum. Clear? They cannot interact with electromagnetic spectrum and the matter thus, okay, because these matter actually they possess mass. They possess mass, they holds mass, but they do not have any charge and they do not emit any light. So that's why. And see, actually like real matter, they does not have any effect with the gravity. Are you getting? So the matter does not have any effect with the gravity and the matter does not have any effect with electromagnetic spectrum. Means radio waves cannot detect, electronic waves cannot detect, magnetic waves cannot detect it, and even gravity also cannot show its influence on these matters. So all these matters are called dark matter, and scientists clearly telling that it does not emit any light. Okay, then it does not have any charge, and but it holds a great mass. It holds a mass. Yes, it holds some mass. So that's why right now everyone, scientists are craving after to look after that. Many physicists who says that they have observed long worlds, they simply saying that actually the present matter what we can see through our naked eye consists of only 5%, and the remaining 95% is consists of dark matter. Clear? So these are the words of physics. Okay, so 95% is of dark matter, only 5% of the universe that is visible to us. 95% of the 95% of the universe is does not visible to us. Clear? So this makes the belief that yes, dark matter and dark energy exists. Clear? The dark matter and dark energy exists. Scientists often say they have pure form of indirect evidences. No one have direct evidence regarding the presence of dark matter. Many scientists hold only the indirect evidence, where indirect evidence through other forms we got that yes, there is some matter that is existing, right? So some indirect evidences and calculations have come with this, and they found yes, these are some elusive particles. These are elusive particles. So that's why I have framed question in that matter. The elusive particles means actually here it does not have any proper clearance, or it does not have any proper substance to explain the things. So those are called elusive in nature. Scientists are calling these particles as elusive particle. Clear? See, if you want to experiment something, actually the latest to hit the news in this dark matter is that there is one dark matter detector experiment that is called Lux Joplin. Okay, Lux Joplin in USA, South Dakota of USA. In United States of America, there is one university and there is one body which is finding after, looking after the dark matter detector, where these detector can experiment and these detectors can detect the signals of dark matter or something. Clear? So they want to interact with the dark matter, they want to interact with the dark matter. So as of today, the most sensitive dark matter detector in the world is this one only. Clear? So what is that? Lux Zeppelin is the only, the sensitive, the most sensitive dark matter detector. Detector means where you can find and observe. Clear? So it gives an idea. Okay, why? Because it is very difficult to maintain these detectors. Okay, Lux Zeppelin is also called LZ detectors. Lux L, Zeppelin Z. Okay, so LZ detectors can detect the minutest ones also. But the problem is the whole detector should be free from any dust or so. Why? Because even a gravest or even a slightest form of dust can differentiate between the observation. Why? Because see, these what we are calling something as cosmic dust or dark matter, it does not have any emission lights, right? So we have to keenly observe each and everything to understand the minutest thing. So that's why even a small amount of dust can deviate the detector. Okay, can deviate the detector. And here the author is quoting example as, see, the whole LZ detector contained only less than 1 gram of dust. Are you getting? This is the high difficulty and this is the high maintenance that they are doing with LZ detectors. Less than 1 gram of dust holds actually all over these LZ detectors. Okay, so this is the reality and they want this. Clear? Why? Because if there is any dust, it may send some other unwanted signals. Clear? The other unwanted signals. So are you getting? So what is the dark matter? See, the matter where we shall be getting some indirect evidences, right? So have this. We see in fundamental forces, this, see, in universe there are four fundamental forces. Fundamental forces. Every particle that we are seeing right now except this dark matter should have this one of the forces. What are those fundamental forces? Those are strong nuclear force. Strong nuclear force. So sir, what is this strong nuclear force and how it helps? Strong nuclear force is the force where it binds the protons, the neutrons and the electrons within the cells. The binding force in an atom is called the strong nuclear force and it is the strongest of all the other four fundamental forces, right? So this is strong nuclear force and there is weak nuclear force. Weak nuclear force. Then what is this weak nuclear force? Weak nuclear force consists of the decaying one, the decaying part. The decaying part of uranium and everything comes under weak nuclear force. Are you getting? The weak nuclear force. Then after that, where we shall be checking that strong nuclear force, weak nuclear force, electromagnetic force. Electromagnetic force. Electromagnetic force where it can actually interact with the particles through electronic media or magnetic sensors. Clear? Through electronic media or magnetic pulses, if it can able to interact with that matter, it is called one of the four fundamental forces only, right? So electronic magnetic force is one of the one and the other one is gravitation. So under gravitation force, every object is being dragged into earth, right? So earth holds a great gravitational one. So all these things are actually observed and they are proved also. These are fundamental forces. And everything comes in particle physics. Clear? So strong nuclear force means where protons, neutrons, electrons bind each other with the atom, and after that weak nuclear force means here the examples of decaying organisms will come, decaying substances, everything comes in weak nuclear force. Clear? So in this way, dark matter, before the dark matter, the actual matter that we have, what we can see, can be clearly visible through these four fundamental forces. But the dark matter which does not have any charge, they cannot interact with electromagnetic interactions, and they do not emit any light. They are black, right? They are dark, right? So the matter contains a normal mass only. Clear? It contains only a normal mass. So that's why it even cannot have interaction with the gravitation. Clear? The gravitational force cannot be observed. So it not only fully integrated, as particle physics call, it is extremely the weak force. This gravitational force is the extremely weak force. Fine? Why? Because the mass of the particles, the mass of the dark matter is such a low that it cannot show any interaction with the gravitational force. So that's why even we are unable to find the exact evidences of dark matter, and still we are going to see it as an LU particle, LU element. Sir, then if you are unable to detect, how can you say it is being existed? Yes, so every your doubt will be solved in this class and in this session. Have this. So what is your question? Sir, if we cannot detect it, how can physicists strongly believe that there exists dark matter? Because see, they have something evidence, I said, that is indirect evidence, right? Those indirect evidence can be found through some various levels. For example, there are some distance scales. There are some distance scales where physicists explain the shortest distance scale is about the rotation. Consider the rotation of galaxies. See, for example, if you go with rotation of galaxies, see, here author is asking, or the example is, if you look at the stars away from the center of any galaxy, the way the velocity means directional movement. What is this velocity? Velocity means directional movement. It has some direction. Clear? Directional movement. Directional movements means, see, earth rotates from west to east. Are you getting? So in this way, west to east or east to west movement, the directional movement is called velocity. If you are standing center of any galaxy, and if you are looking the velocities, and if you observe stars, and if you want to plot that on the paper, if you want to plot that, okay, if the same is done in the lab, and if you are plotting on the graph, assuming the visible matter is all that exists, if you take only visible matter exists in the matter, only visible matter exists in that area, and if you have that graph, the original graph, see, the original things, and your graphed one, where you are taking all the matter is visible, these two would get some difference. Then what scientists have done? Scientists have taken something called dark matter. They accept that yes, there is something that is called dark matter that is existing, and after taking dark matter into consideration, the original one and the graphed one have become equals. Are you getting? So this clearly shows that in the original matter there is something that is called dark matter. So what is happening? Initially, if you look at the galaxies, and if you plot the rotation of galaxies, and if you consider all the matter in the universe is visible, then have that graph in the lab, he is asking. And in the same way, take the original one and the graphed one, you shall be looking some difference, okay. So after that, take this, okay, the difference should be plugged, right? So scientists then started believing that yes, there is dark matter, and have given some value to it. If you do that in the lab again and again, after taking consideration of dark matter, yes, both these original one and the graphed one have become similarities. Clear? Both these have become similarities. Think you got how distance scales actually helped in finding the dark matter, right? So here the author also has given other example. Please look at this. Author is asking to certain have some certain fraction of matter, certain fraction of matter which exerts a gravitational pull, okay, which exerts a gravitational pull, a gravitational pull on the rest of the stars, okay, rest of the stars in the galaxy, for it cannot be seen in any other way. Means here see, now okay, see, when you observe certain fraction of matter and take the gravitational pull, that is gravitational pull that should be against the stars, okay, okay, when you put this gravitational pull on the rest of the stars and if you observe the value, you will get value difference, you will get the value difference. The value difference can be equated or can be solved only after accepting there is certain amount of dark matter that is existing there. Are you getting? So there is certain amount of dark matter that is existing there, right? So but one may argue that this model is a faulty one, okay, and this has to be reconciled between calculations and rotation galaxies. But there are other evidences also which shows that yes, most of the people have come and accepted that yes, there is presence of what is this, that is called dark matter. Then what are the evidences from other distance scales, see, the universe can be observed at various levels. Means you can observe the universe at electronic level, at nuclei level, at atoms level, right? You can observe the earth at or the universe at electronic level, nuclei level, atoms level, or even at the level of galaxies, even at the level of galaxies or galaxy cluster. So this galaxy cluster means group of galaxies or even a large distance where you can cover the entire map, okay, so where you can cover the entire the map of every galaxy. So this is what the author was asking, okay. Let's have the consideration from the part of galaxies and galaxy cluster. Means if you start observing from the viewpoint of galaxies or by taking the position of galaxy and galaxy cluster, then you can observe the differences. Clear? Here the cosmologists, sir, who are cosmologists? Cosmologists or physicists, okay, cosmologists are physicists where they observe the actual pattern of universe, okay. Here these are physicists who observe in the universe, those are called cosmologists. Clear? Then people started studying this part, okay, and they mentioned that these galaxies, the galaxy clusters have the lowest and even the smaller scales, okay. When you observe from electron, neutron, atoms, you shall be getting one value, but when you are observing from the part of galaxies and galaxy cluster, there is some even smaller values. The reduction of value can be observed, can be understood only by accepting that yes, there exists something that is called the dark matter, right? There is other evidence also. The other evidence is called bullet cluster of galaxies. Bullet cluster of galaxies. Clear? So bullet cluster of galaxies, where these are formed by merging of two galaxies. These are formed by merging of two galaxy clusters. These are formed after merging of two galaxy clusters. Fine. So physicists found that the calculations that the mergers have taken place cannot fully explained, okay. With the present knowledge, we are unable to explain the merging of these two galaxies. The merging of two galaxies often have some lackings, and everyone accepted that this lackings is because of lack of knowledge on dark matter. As dark matter is an elusive one, here also we are unable to getting the proper understanding of the merger of these two galaxy clusters. In general, in science, the cosmologists able to explain the mergers of other galaxies, but here when two galaxy clusters started merging, they did not get the whole information because they lacked something. Why? Because there exists dark matter, and this is also one of the indirect evidences where we can observe, yes, the presence of dark matter. In the same way, the similar argument have come from the universe, that is called, there is some educational institution or the survey that is called Sloan Digital Sky Survey. Sloan Digital Sky Survey. Clear? They studied the filamentous nature of universe. Sir, what is this filamentous nature? Filamentous nature means filamentous nature of universe. Filament, you know, right? What we call something that is coming out of the structure of filament in nature. The structure of filament in nature is called filamentous nature. Okay, so filamentous nature of universe actually have to be closerly looked here. These are the words of Sloan Digital Sky. Why? Because we cannot explain these things with our present knowledge. Why? Because there exists some matter. These are the words of Sloan Digital Sky Survey. So most of the students, most of the aspirants, most of the scientists who are studying the universe in a different perspective are greatly accepting the presence of dark matter. Clear? Their presence of dark matter. Then what are the candidates for dark matter particles? Means to observe dark matter particles, how can we clearly say that? If possible, if you observe in future also, if we are able to observe the dark matter, then whom should be the candidates? Clear? This is the question, right? Here there is one person, he is called Gopal Krishna from the Institute of Mathematical Sciences from Chennai. He said there are some neutrinos. Neutrinos are extremely light particles. Okay, so these are extremely light particles. Often we say that these have taken birth at the time of universe, and there are large number of neutrinos. Actually, recently we have come to know, yes, there is presence of neutrinos, and we often say neutrinos exist everywhere in the universe. Okay, everywhere in the galaxy. These neutrinos are very small, but this Gopal Krishna have said neutrinos can become or might become the excellent candidates if they have some massiveness, if they have some mass, some more mass to detect. It could be the proper candidate to observe the dark matter. Why? Because see, these neutrinos does not show any effect on the matter. These are effectless bodies. Actually, they does not show any effect if they pass on through any body. For example, let's take this movement. Even in this movement, lakhs of neutrinos pass through our body without any interactions. So that's why we don't get any difference. Because lakhs of neutrinos actually pass through our body every second, but we cannot able to observe through our naked eye because of its presence of size, and because of its lack of mass, and because of its lack of massiveness. Clear? So these are the things that the author is explaining here, but they are also telling there are some particles which are called bosons. Okay, which are called bosons, and recently we have done Higgs boson experiment, and through those we found bosons. Okay, these are bosons, a particle that mediates the electro weak interaction. Clear? These are the weak interactions, bosons. Clear? Okay, and they said there are some hidden particles. These hidden particles are called axions. We don't need that much knowledge or that much depth to our UPSC, but we actually say yes. But see, here scientists are accepting with the evidences, with the indirect evidences that is present in the world, and they are taking that yes, there is dark matter that exists in the world, but that is in elusive nature. Clear? So here the candidates could be one which can spin together with gravity. Clear? So what is this? they have used something that is called supersymmetry. Supersymmetry means every particle holds spins. Spin means rotation. Every particle holds rotation speed. Okay, even Earth holds, we hold, every particle holds spin, the rotation capacity. Here the supersymmetry means it can rotate. It can rotate, but its rotation can be observed only after its two-time rotations. Two-time rotations. Why? Because see, for every rotation, see, if there is one particle, that is called supersymmetry. For example, bosons are supersymmetries. For boson, when you do one spin, we cannot observe it. We can observe it only if it does the two spins. Okay, only if it does two spins, then only we can observe. Why? Because for every first spin, they create the negativeness, so that we cannot observe. Only after the second one, they create the positive one, then only we can observe these neutrinos or these bosons who are very supersymmetry. So authors here clearly observing that when we able to do this supersymmetry with the gravity, then we can get some of the knowledge that is existing in the world as dark matter and dark energy. So I think, see, I have cleared your article to the required level of extent of UPSC that might ask the questions. Clear? So yes, and right now check, we shall going to discuss the question in general. Fine. The question, still the concept of dark matter is an elusive one. Explain. So here you have to go with introduction. The introduction part should be very clear and very fine. So scientists often take, there exists some matter that is called dark matter that does not show any interaction. Does not show any interaction, and they does not have any charge particles. They does not have any charge particles, and they does not emit also. No charge, no actually have interaction, no charge, and does not emit light. So these are called dark matter, and scientists accepted the presence of 95% matter in the universe as dark matter. And after that you have to come with the body. In body, where you have to show the nuclear forces, that is the four fundamental forces cannot observe the dark matter. The four fundamental forces being the strong gravitational force, the weak gravitational force, and after that the gravitational force, and after that the electromagnetic force, right? The strong nuclear force, the weak nuclear force, the gravitational force, and the electromagnetic force. These four fundamental forces cannot show any interaction with the dark matter. This has made the dark matter as elusive one, where we cannot explain. Okay, but there are some indirect evidences. These indirect evidences should be come by you through examples. First one, what I said, distance scales. And after that, when you observe at the matter of galaxies and galaxy clusters, you can observe the indirect evidence, and through merger of two galaxy clusters in the form of bullet galaxy cluster. So are you getting? Galaxy cluster. So in this we can observe the dark matter is an elusive one. So what is that conclusion you can go? The conclusion should be, when we able to do the bosons as supersymmetry, as these are supersymmetry particles. The supersymmetry particles, when we able to have the spin with the gravitational force, then we can get some evidences, and still lots of research has to put by all the stakeholders. Okay, then only we can clearly observe the things in clear, and then only we can observe some information related to matter or dark matter, right? So this is the whole article. See, we do lot of research and we put lot of hard work to deliver these videos, and we think that you appreciate our expectations. And I wish, please do hit the like button, please comment, so how we are discussing and everything, that provides some rejuvenation. And I encourage everyone to participate in this question part, and where I shall be reviewing our answer. Clear? Yes. Bye.